The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, and welcome to Hackett's Cove, Nova Scotia. Welcome to Nautel's webinar on push radio, a new concept in distribution of audio to transmitter sites. I'm Chuck Kelly, and very glad to have everyone with us today. We've got quite a number of people signed up for this, and looking forward to sharing our concepts and our ideas with you. This is absolutely an interactive presentation, and we are looking forward to your concepts and your ideas as well as we discuss this as time goes by. We're going to talk about today the traditional studio transmitter model. We're going to talk about new technologies which are becoming available, which enable new concepts to occur. We're going to talk about our new push radio model and the benefits of push radio, which include localism, flexibility, the opportunity for one-to-many, and tremendous cost savings. And we're going to have time for questions. And within the webinar format, those of you who are listening to this live at this point will have an opportunity to ask questions. And in order to make that happen, you'll notice that in the player that you're using there, there's an opportunity for you to type in a question and then hit send, and we will, at the end of this presentation, go through the questions that have come in and attempt to answer them. If you're seeing this webinar in a recorded fashion where we've archived it and put it on our web page, you can still ask questions. You just send them as an email to me, and I'd be very happy to answer any questions that you may have. So let's talk about the traditional studio transmitter model. In a radio station, the left side of this page is the studio, and the right side of this page is the transmitter site. And in the studio, we have the centralized audio content, or the studio content. In the middle, we have the studio to transmitter link of whatever kind it is, whether it's microwave or telephone lines or satellite. And on the right-hand side, we've got the transmitter site. Pretty standard stuff. In the traditional radio model, the roles that these things have, the studio has the role of the mass storage of audio content. It can create and import the new content, manipulate the playlist of what's going on over the air. The STL, of course, has the role to convey the audio content to the transmitter in real time. And the transmitter has the role of simply airing that incoming audio stream. Again, very basic, but it's important that we look at these models so that we understand what's changing. The problems with traditional STLs, and many broadcast engineers will know this automatically, microwave STLs are costly, and they suffer potentially from interference and blockage when new buildings go up. Many cases in metro areas, the frequencies are so congested that it's almost impossible to get a new STL frequency through. And many older analog STLs compromise the audio quality. It's been true for many years now that the studio audio performance and even the transmitter audio performance are better than that of the analog STL. So the analog STL has been the weak link in audio performance for many radio stations. And these traditional STLs are a single point failure. If they go down, the whole stations go down. And even though you may have multiple studios in your transmitter site, or you may even have main alternate transmitters, you have a single point failure in many cases in a studio to transmitter link. Telephone lines, many stations have used telephone lines as an STL. They're increasingly difficult to obtain. I was listening to or reading some of the engineering blogs online and talking about people trying to negotiate with the telephone company to put in new copper pairs, and very difficult to do in many parts of the world these days. They are also capable of compromising audio performance. Many people have been talking for years about the telephone company flipped a line over completely out of phase, or the noise level, the frequency response has been compromised. And then, of course, you're trying to deal with the telephone company when you're in an off-the-air situation. So there have been frustrations over the years with telephone lines, and they are a substantial monthly expense to boot. Satellite, it's very expensive, but it handles large geographic distribution well. I can have hundreds of stations, potentially hundreds of transmitters, all taking the same satellite downlink, and this could be a very cost-effective, once you think about the number of transmitters, way of distributing audio to many transmitter sites with large distances involved. Of course, nothing is perfect. Satellites suffer from sun outages. Every year you will have an outage, and depending on the size of your dish, it could be multiple days. It could actually happen at 11:59 in the morning on 3 consecutive days or something like that. So let's talk about what is changing in the industry as we speak. The disruptive technologies that are going on, things that are causing change in our industry. Microwave and satellite STLs, in many cases, are moving to Internet or at least TCP/IP distribution. It may be that you're using some sort of microwave STL, which is IP-based. We also have the transmitter is moving potentially to an intelligent transmitter, and we'll talk more about what that involves, and the possibility of moving from centralized storage to distributed storage and the advantages therein. So let's talk about the Internet as an STL. The Internet as an STL is very inexpensive. Many sites that stations have already have Internet coverage, an Internet connection, and in cases of cable modems and things like that, they can be pretty high instantaneous data rates. Many studios and some transmitter sites already have the high-speed Internet. It tends to be unreliable, potentially, for long-term, real-time delivery of content. It's no big deal if you're sending a file someplace, if the file takes a minute to get there instead of 10 seconds, but it's a big deal if it interrupts an audio stream. And so Internet can be very reliable for non-real-time file delivery, but unreliable for long-term, real-time delivery of content. So let's talk about what do we mean when we say an intelligent transmitter. The VS series from Nautel, the low-power VS series, is available as 300 watts, 1 kilowatt, or actually 1.4 kilowatts, and 2.5 kilowatts. And this is a new series of transmitters. We've talked about them before in our webinars. But they feature IP connectivity. They are probably the most IP conversant transmitters that you'll ever run into in the world. And that IP connectivity includes an internal web server which is built into the transmitter that gives you the capability of monitoring and controlling the transmitter in depth. And we will actually take the opportunity during today's webinar and show you what we mean by that. The IP connectivity also facilitates the transmission of real-time content. So we can actually, for the first time, use the Internet as a transmission tool to get real-time content there. And we'll explain that in more detail as well. And then the IP connectivity, or the VS, also includes local content storage. There is a USB jack in the back of the VS series which allows you to plug in USB storage. And that storage could be either a RAM card, the ubiquitous lipstick USB storage, or it could be a hard drive, a USB hard drive that is plugged in there with terabytes worth of storage potentially. And you can upload via IP, via that Cat5 connector on the back of the transmitter, new content to the USB drive via IP. It's sort of like the transmitter says, okay, you've got me connected to the Internet, and you've connected up a memory stick to me. Well, I'll just create an FTP site on that memory stick for you. And the transmitter also includes the capability to create playlists and modify those playlists as well. So you can remotely, through the IP connectivity, through the web server, you can create a playlist, choose from the cuts on the memory stick, and arrange them in a playlist, modify that playlist, and air that playlist. And so the web access is also for the playlist creation and modification. In addition to that, because the VS series has so many different audio connection inputs, in other words, I can connect into this thing via analog left and right, AES EBU, shoutcast, live wire, and the internal storage on USB. Because we had all of those individual methods of getting audio into the transmitter, it was necessary, because the only place the audio processing could occur with such a variety of audio sources and the capability of switching dynamically among them, it was important to have the audio processing available inside. So we actually created a high-speed DSP card which fits inside, as an option, inside the VS series, and then we licensed the code for the Orban 5500 series and put it on that card. And that includes everything, all the multiband processors and all of that stuff. It does not include the output stereo generator, because we do the stereo generation in the transmitter, which also means we don't have some of the composite clipping functionality that is a part of the, or composite control functionality that is a part of the Orban. So let's do this right now. Let's go over and take a look at an actual VS series in the lab at the moment. And let's look over the shoulder of the engineers there. So this is what you're seeing now is an actual VS series transmitter, and it is operating in the lab. And you can see here the main screen. We're running it only at 90 watts at the moment. You can see there's audio over here on the exciter. Here's a spectrum analyzer, which is showing the performance of the transmitter at the moment. And I can enlarge that, and we can see how it looks. We can compare it with an HD mask, for instance, even though we're running an analog in this particular situation. And I can also switch it over and take a look at the multiplex composite baseband. And so what's happening here is I can see the analog left plus right. I can see the RDS signal. In this particular case, I'm seeing that's the 19 kilohertz double sideband suppressed carrier. So let's go back here, and then we'll clear averaging and hit OK. And now we're back to that. We'll put that away. Let's take a look at what else we've got on the screen. We've got an EQ frequency response graph. We have, this is the Orban inside audio processor. We have a Lissajous plot, which is showing the left and right audio in the phase relationships, the amplitude relationships between them. So it's a very simple way of seeing that I have audio coming into this transmitter. Let's also, what we're really looking for here is talking about what we mentioned about the audio player built in. So over here, I have the audio player screen under software configuration, and here's the cuts that are currently on the memory stick that's connected to the back of the transmitter, and then here's the playlist that we've created. Now I can actually add new cuts to this playlist, and that's easy to do. I can also manipulate the cuts in the playlist. I can move this one down, for instance, in the playlist, and then resave the playlist. So here's the functionality, and I can also then upload files. So here I am sitting remotely from this transmitter. I can upload new files into the transmitter from here, and they're stored then on that memory stick. And this becomes a very effective way to utilize the storage in this transmitter. So what we've been talking about here is the enabling technologies of a smart transmitter, the ability of the transmitter to play its own playlist, run its own audio processing. We also have the capability in this transmitter of making some decisions based on what's going on. So for instance, over here under main audio, we are currently playing a playlist. And over here under other audio, I am saying right now, if there's an audio loss timeout, do we want to do something about it? Yeah, well, we want to change the preset. Okay, and we'll change it to this particular preset. We'll choose a preset here. So and what this really means is, suppose I'm bringing audio in from AES EBU, I'm putting it on air, the AES EBU fails for whatever reason. It could be the studio has gone down, the STL has gone down, what have you. The transmitter will sense the audio loss, and it's defined as 10 seconds, in this case, 0 minutes, 10 seconds, at a threshold of less than 20%. I can change that, obviously. It sees that silence, and it causes a change in the preset. So That's functionality that's built into the transmitter. So now let's go back and talk about, now that we have this intelligence in the transmitter, what could we potentially do with it, looking at what we've been discussing about the functionality of the transmitter in a total studio design package. So moving on here. So let's talk about the push radio studio transmit model. Push radio is a phrase that we developed to try to explain our concept here. And again, we're looking at the standard configuration of a station where you have the studio here, the centralized audio content, a real-time STL here, and a transmitter. What we do potentially is add low-cost internet, real-time internet connection, and we change the transmitter to an intelligent transmitter, and we change the storage to distributed storage, and we move a USB hard drive or USB memory stick over to the transmitter. Now, when we've done that, and we now have the capability of executing playlists over here, what's happened is potentially we have the ability to store the content of the transmitter. We have the potential for executing the playlist locally. The new content, the changed content, is uploaded via IP. So the playlist is able to be modified via web access. So let's talk about how this could work in a conventional station. We can combine the traditional approach with the push radio approach. So for instance, local playout of stored content can be limited to STL or studio fault conditions. If your STL dies, if your studio, the power goes off in your studios, you can let the transmitter automatically pick up the ball, start playing off a playlist, and you have a backup even when your studio is dark. Live broadcast via conventional STL or IP streams can be used, switching to stored content during specific day parts. So you can have a live show, a morning show, for instance, a morning drive show, which is sent to the station in real-time format, either via IP or conventional STL, and then you can switch to an automation running on your transmitter when that's necessary during specified day parts. Or you could have another model where most programming could come from the local content, switching to an IP stream only for such things as newscast, live call-in shows, or sporting events where you absolutely have to have live content. So what are the benefits in terms of large networks? Well, around the world, there are a class of stations, tend to be educational or religiocaster types of networks, where you literally have hundreds of low-powered FM transmitters, and their content is distributed to these large networks, typically via satellite, because they're distributed over a large geographic area. So you've got numerous low-power FM transmitters distributed over a large geographic area, and its content is distributed to the transmitters via satellite. The problem is that the satellite carries with it high satellite distribution operating expenses. Oftentimes it's the largest single expense in these networks. In the push radio model, you could potentially get rid of completely that distribution, that satellite distribution expense, and save a tremendous amount of money. And meanwhile, since the satellite, which suffers from sun fade, is gone away, the reliability potentially could be improved. And while you could say, okay, well, what about the reliability of the IP network? Remember that with push radio, with storage locally in the transmitter and local execution of a playlist, if the internet goes down, all you've lost is the ability to update the playlist. The radio station is still continuing on the air. Another major benefit of push radio is that in the case of satellite distribution, we often sacrifice localism. Imagine if you've got a satellite radio station distributed to many individual local stations going straight on the air. The weather forecast is not appropriate necessarily for all of the stations. The newscast may not be appropriate for all of the stations. It may be desirable to have local commercials, local news, local weather, and with the push radio model, the weather forecast, the local news announcements, commercials can be pushed out differently to different transmitters. So you can have your cake and eat it too. You can have your broad geographical distribution with one common head end, if you will, of program source, but at the same time preserving localism, for making that individual station in each of those small towns with those small transmitters be appropriate, specific to those specific communities. What about higher stations? What if the VS power of 300 watt, 1.4 kilowatt, and 2.5 kilowatts isn't enough? What if I need a network of 10 kilowatt transmitters or 40 kilowatt transmitters? Well, the VS series is actually an ideal exciter. The 300 watt version can be used as an exciter for many high-powered transmitters. As a matter of fact, I know a number of stations that are using a VS300 or even a VS1, the 1.4 kilowatt model, as not only the exciter, but they're also replacing the IPA at the same time. It may have been an older technology. It may have tubes that are no longer available. It may be expensive to maintain. So they're using the VS300 as a very inexpensive way to replace not only the exciter as well as the IPA and gain all the benefits that we've been talking about with regard to push radio and these sorts of things. And the cost of the VS300 could be as low as $5,000. Now, it doesn't include the Orban Inside processor, but $5,000. The Orban Inside is only another $1,200 on top of that. So what about really large networks like we've been talking about? The basic push radio functionality exists in the Nautel VS series today. However, it could be pretty darn time-consuming to keep everything updated when there's hundreds of transmitters involved. How do you make sure that all of those hundreds of VS transmitters in the large geographic area all have the most recent weather forecast or the most recent song we're about to put on the air? That would be time-consuming. How do you make sure all their playlists are updated? Well, we are working at this point in time with a major automation provider to develop software to control VS transmitters. So this automation provider is typically in the business of controlling sound cards and putting formats on the air, interfacing the traffic and billing logs or schedules into the program schedule, and then controlling sound cards. Well, in this case, what it will do is to take those same traffic and billing systems, interface them into a program schedule, but distribute it to, instead of speaking the language of a sound card, it's speaking the language of the VS transmitters. And we are working with a major automation provider to develop that capability. And it ensures that all the transmitters have the required content as well as the updated playlist. And furthermore, brings back the as-played logs for reconciliation with the traffic and billing and the music scheduling systems, which really closes the loop in the entire radio station environment. So as a summary, the push radio technology that we've developed leverages the intelligent transmitters, distributed content, and the low-cost internet technologies, and makes possible the ability to store the content in the transmitter and execute the playlist locally at the stations, which then benefits in terms of improving localism, improving the flexibility for the station, the reliability of the station, makes possible very cost-effective one-to-many types of large networks, and can also make tremendous savings for the radio station. So what we would like to do right now, if it's possible, is to answer your questions. I see a number of questions here. Let me go ahead and start answering them. First one is from a, let me see if I can pull the name up here. This technology is so cool. Let me get this here. Okay. So Randy has asked, you haven't mentioned HD. Is localized HD possible? I'm assuming there's not, since there's no exporter option in the transmitter. Well, actually, you're right. As it exists today, push radio is a technology which applies to analog FM stations. However, the capability of push radio potentially can be entered into either the exporter or the importer if you want to do it on one of the multi-channels or multicast channels, and that would mean that you would have the capability of doing this. We've also had another question about, will you add these features to the NV series? There's work going on to make something like that possible in the future. and potentially even to AM transmitters. This is also possible. It says, how does the stereo generation happen if the built-in OR band doesn't include it? That's from Laverne. Well, the VS transmitter, as it stands today, has a built-in stereo generator because it has the capability of bringing in AES EBU or left and right analog audio or playing things off of the memory stick. And so the stereo generation is occurring directly into the transmitter. And so that's where that functionality occurs. There's a question from a gentleman who's asking about more specifics about the automation opportunity we have for large stations, and I can't really release any information at this point, but we are very excited about the possibility of working with large networks to understand what their needs will be and fine-tuning what we're working on to meet the needs of these large networks. Obviously, many large networks have different needs, and we want to make sure that when we're doing our development and cooperation in this process, we get it right the first time. So we are in a mode of information gathering with regard to the development for this automation project for very large networks, and your comments and thoughts will be very welcome in that regard. That's also part of the reason for the webinar today. Another question, the NB series transmitter software is compatible with broadcast software hard data HDX. I'm not sure I understand that question. It may be that we're talking about another automation system. Certainly the audio formats on the memory sticks are compatible with several audio formats, including a standard linear digital audio format like a WAV file or MP3 encoded files. And before you turn your nose up at MP3 encoded files, if you're using a high enough sample rate, they sound pretty reasonable. So these are the functionality in terms of being compatible with broadcast software today. With the audio files, that functionality should be pretty good. With regard to playlist compatibility, I don't think that exists today. Randy has asked, with local playlists, how does it handle segues or music overlap? That's something we're working on. Right now, it's butting. So you've got multiple cuts butting. And a lot, as I mentioned, some of the stations we're targeting with this are ones that run block programming, educational broadcasters, religious casters, things like that. So that the songs may not necessarily at the moment segue, although that's certainly something that is in the development process to cause segueing. But the VS transmitter today butts songs together. What security is used to protect the FTP server? Well, there's certainly all the passwords and sort of things that are a part of that, but we would also recommend the possibility of, and then there's multiple layers, I should say, of security in the VS transmitter, multiple types of users and that sort of thing. But certainly going behind a firewall, utilizing a VPN, would all be very, very smart ways of handling security for these kinds of systems. It says, does the built-in OR band need to be used for both the STL feed and the locally stored audio? Well, the OR band can be, let me switch to the live transmitter and show you how that works. We will switch over here, and now I'm going to move this question out of the way. Now I can go over here and bring this up and go into the presets. Now, in the VS series, we have 60 different presets. And these presets are all the settings that relate to the transmitter. So, for instance, in this setting, we are, on this preset that I'm editing right now, the frequency is 90.0, or sorry, the output power is 90 watts. Frequency is 101.5. The mode is FM as opposed to some sort of HD mode. The main audio is coming from a secondary digital source, which is a playlist, but we could have also had shoutcasts and other various configurations of live wire, that sort of thing could have been choices there as well. Or we could choose left-right mono, composite, primary digital, which means AES EBU. We can also configure here our SCA and our RDS. All of these functions are built into the VS series. But when I come over again to this other audio tab, we also have the capability of setting up the Orban processor. So if I enable the audio processor, the Orban audio processor, I can choose the preset here. So this is part of a preset. So it would be very easy to have a preset that chose this particular audio input and didn't use Orban, and switch over to this one, which does use Orban. And not only that, but I could also switch the Orban presets. All the normal Orban presets that you're used to seeing as you work with an Orban processor are available on this screen as well. I hope that answered that question. Let me switch back over here to the questions and see if there's any more. It says, will the local storage support larger drives in the range of 1 terabyte or more? That's from Jonathan. I don't know the answer to that. I'll have to, Jonathan, I'll have to, your email is here, so I'll have to find the answer out of that. I have used multiple gigabyte drives, and that seems worked out very, very well. But I haven't used a terabyte or larger USB hard drive, for instance. But that's one of the things I'm going to be working on. Randy asks, he says, I think you mentioned live wire. Is that a built-in audio option, or is it an option in total? It's a built-in audio option. We have worked very hard with the people from Axia, and there are a number of very happy Axia users around the world who wanted the ability to just simply plug a Cat5 cable in the back of our transmitter and have the live wire audio come in from their digital studios, go straight into the transmitter, and that's built in, that's standard, and that ships with every unit. And we're very proud of that. It's probably a feature which makes sense only in situations where the transmitter side is co-located with the studio because of the bandwidth requirements of a live wire installation. I believe we have answered all the questions that I can see here to date. So I will continue on here for just a second. And if you have any more questions, let me know here before I get anything switched. Let's see here. Okay. So let's say other things, other tools, other places you can go for information include the Nautel Waves newsletter. We just sent out another one yesterday. Lots of good information there about digital radio, about tips and tricks. Probably the most popular part of our Nautel Waves newsletter. But a lot of good information there. Included in this one is an article about our head of production and his philosophy in producing quality products. You'll find an archive of all the webinars that we've done, and this one will be showing up there soon, so if you didn't catch the whole thing, you can go there and pick it up. You'll find a number of videos on our YouTube site, and you'll find those will be very, very useful. And don't forget the Nautel store, which is the ability to go online and order parts and or even VS transmitters right there in the Nautel store, store.nautel.com. So we're proud of the things that we're trying to do to be accessible to our customers. If there's questions, we're ready to help. You can direct those questions to sales@nautel.com, or you can talk to one of your Nautel sales representatives, which are listed below. I thank you very much for sharing 35 minutes with us of your day, and we look forward to seeing you at future Nautel webinars. For right now, for Chuck Kelly, thank you very much, and have yourself a wonderful day.